In this video, we're going to learn about dilations. First of all, what is a dilation? Let's look at a definition. A dilation is a transformation that multiplies the distances of points by some scale factor relative to some center. So why don't we go ahead and do some examples of dilations. First example, on the left here, plot the image of PQ under a dilation xy maps to 2x 2y, centered at the origin with scale factor 2. Alright, so we want to take this segment here, PQ, and transform it by the dilation which is centered at the origin with scale factor 2. We're given the dilation in function notation here, xy maps to 2x 2y, so we can figure out the image of PQ by just running the endpoints P and Q through that function. First, let's take the endpoint P. P is the point 3, 1, and that gets mapped to the point P prime, which according to the function takes the original x coordinate here, which is 3, and multiplies it by 2. So 2 times 3, and then it's the same idea for the y coordinate, 2 times the original y, so 2 times 1. And the result there, 2 times 3 is 6, 2 times 1 is 2. So P prime goes to 6, 2. We can do the same thing for Q here. So Q is the point 2, 2, and that gets mapped to the new point Q prime, which is 2 times the original x coordinate 2, and then 2 times the original y coordinate, which is also 2. So Q prime really has coordinates 4, 4. Let's go ahead and plot that. It's right up here. All the other points in the segment follow suit, so we can just go ahead and draw them in by filling in the segment between P prime and Q prime. Now, why don't we go ahead and verify that this is actually a dilation centered at the origin with scale factor 2. So there's the origin, that's supposed to be the center of this dilation, and then the distances of points on PQ are supposed to be multiplied by the scale factor 2 relative to the center. Why don't we go ahead and draw in some guidelines for ourselves. So here's the distance from the origin to Q, and then we'll go ahead and keep filling that in to get to the distance from the origin to Q prime, and we'll do the same thing for P. And after we're done, we'll look at that and verify that it is indeed twice the distance to the new image. Alright, so let's check. The distance to Q is diagonal across 2 units, and the distance to Q prime is diagonal across 4 units. So yeah, the new distance ended up getting multiplied by a scale factor of 2, because 2 times 2 is 4. The new point Q prime is twice as far away from the origin as the original point. And now for P, we see that was originally 3 over 1 up, and the distance of the image P prime does that whole process twice. 3 over 1 up, 3 over 1 up. So it is in fact twice as far from the origin as the original point. Alright, so let's go on to the next problem here. Plot the image of AB under a dilation centered at 1, 1 with scale factor 1/2. Now, we're not given the actual function this time, so we can't just plug in our points. We're going to have to do this geometrically. And the way we do that is by starting out plotting the center, 1, 1. Now let's go ahead and draw lines through the endpoints of this segment. So here will be a line through B, and then here will be a line through A. The dilation has scale factor 1/2, so that means the distances of the new points from the center 1, 1 need to be half as much as they originally were. For example, the distance to A from the center is currently 4. So the new point A prime should be a distance of 2 from the center along the same line. So let's go ahead and count 1, 2. So A prime is right over here. And that makes sense because it cuts the distance to A halfway. Now on to B. Right now the distance from the center to B is diagonally across 2 units. So we need to cut that distance in half, only go diagonally across 1 unit. So here's where the new point ends up. B prime diagonally across just 1 unit. And we can just fill in between A prime and B prime to follow suit for all the other points on the segment. Alright, on to the third problem. Plot the image of LM under a dilation centered at 1, 2 with scale factor -3. A negative scale factor might sound kind of confusing, but don't worry, let's just take this step by step, first plotting the center as usual. So plot the center 1, 2, it's right here, and then draw the lines through the endpoints of the segment. So through L and through M. Now let's think about the negative scale factor. If this were a scale factor of +3, these points L and M would be getting 3 times the distance further from the center in the same direction that they already reside. So L would be going up and M would be going to the right. But because our scale factor is -3, the new points will be 3 times the distance away from the center, but in the opposite direction. So L, instead of going upward, will be moving downward in the opposite direction. And the distance gets multiplied by 3. Originally the distance is just 1 unit up, so now when we multiply by -3, we're really going 3 units down. So 1, 2, 3, and this is the new point, L prime. It's the same idea for M. M is currently 2 units away going to the right, so when we apply that scale factor of -3, we should be 6 units away going to the left. So 1, 2, 3, 4, 5, 6. And there's our point M prime. Then we just go ahead and connect up this segment to apply the same kind of transformation to all the other points, and then we're done. Alright, here's another problem. Find the center and scale factor of the dilation that transforms the triangle ABC into triangle A prime, B prime, C prime. First, let's focus on finding the center. Remember that each pair of corresponding points has to lie on the same line including the center. So the idea here is we can just construct the line through each pair of corresponding points, and then where the lines intersect, that'll be the center. So let's go ahead and construct this line between A and A prime. We'll also construct a line between B and B prime. And we can already see where they intersect. It's right over there. And indeed, that also lies on the line containing C and C prime. Let's not draw it in though to avoid overcrowding the diagram. So we have the center. We can go ahead and write that down. The center is the point 0, 2. And now we can go ahead and pick out the scale factor. Looking at the points A and A prime, A was 3 units diagonally from the center. There was 1, 2, 3. But A prime is only 1 unit diagonally from the center. So the ratio of distances there, A prime is 1, A is 3, 1 to 3, that gives us our scale factor. So scale factor is 1 to 3, or just a third. And let's just go ahead and verify that that makes sense for all the other points. Point B was originally 1, 2, 3 diagonal units from the center, and now the point B prime is just 1 diagonal unit from the center. So yeah, that also makes sense that the scale factor would be 1/3. And lastly, let's check for C and C prime. Point C was down 3 and over 9. So applying a scale factor of 1/3, we should be just going down 1 and over 3 to C prime. And indeed, that's right, that's where C prime is. So there we go. There's our center and scale factor for the dilation. Now we know how to apply and reverse engineer dilations. And in the future, we'll continue learning about different kinds of transformations that we can apply to geometric figures.